Hi, my name is Sei Saito, research professor of Arctic Research Center, Hokkaido University, Japan. I am overall lead PI of the RACArctic project. RACArctic is resilience and adaptive capacity of Arctic marine systems under the changing climate. This is a synthesis project that ran from mid-2015 to mid-2019. Participant country consists of USA, Norway, and Japan. 3 co-PIs, Franz Mutter of UF from USA, Ken Longwa of IMR from Norway, and myself from Japan led the RACArctic project. The project was developed by ESAS, the Ecosystem Study of Subarctic Arctic Seas, one of INBA regional program. The goal of this project is to synthesize recent trend and future projections of climate change and ocean acidification and the impact on subarctic, Arctic marine ecosystems in the transition zone between subarctic, Arctic regions, with a focus on fisheries, fisheries-dependent communities, and fisheries management.
Hi, I'm Ken Drinkwater, a physical oceanographer from the Institute of Marine Research in Bergen, Norway, and the lead PI for the RACArctic project in Norway. Overall, the RACArctic project involved 19 PIs from a total of 11 institutions across the 3 countries, Japan, the US, and Norway. As Dr. Saito mentioned, the project focused geographically on the Arctic subarctic transition zones, also referred to as the gateways to the Arctic. Specifically, we were interested in the Bering Strait in the Pacific and Franz Strait and the Barents Sea in the Atlantic.
Hi, I'm Franz Müller, a fisheries oceanographer at the University of Alaska Fairbanks, and I'm the US lead for RACArctic. The US team included natural and social scientists with expertise in oceanography, fisheries, marine ecology, economics, polar studies, and others. We hosted a stakeholder meeting and workshop here in Juneau that included participants with a stake in Alaska's fisheries resources, from subsistence users to commercial fishing groups, and from environmental NGOs to local and regional management agencies and other governmental organizations.
So the way we approached this was by first conducting an extensive literature review with a focus on recent studies from the 3 member countries. We held scientific workshops in each country to start the synthesis process and held stakeholder meetings in each country to discuss the implications of physical and biological changes to stakeholders and the associated opportunities and challenges. The synthesis papers, which are listed on the right here, will appear in a special theme issue in the ICES Journal of Marine Science. This schematic summarizes some of the effects of changes in CO2 levels on high latitude marine systems through changes in temperature and ocean acidification. The big and obvious changes are, of course, loss of sea ice that directly affects living habitat of a number of species living on or in the ice and results in a longer ice-free season, which leads to an increase in light in the ocean, a longer growing season, as well as to changes in the timing of the spring bloom and other events, and perhaps the addition of new fall blooms. These changes affect plants and animals in the ocean in a number of ways, with direct effects of changes in temperature and ocean acidification on the growth and physiology of a number of species, in particular shellfish, as well as direct effects of warming on the spatial distribution of organisms as they try to stay within their preferred temperature range. And this has already led to large northward shifts of fish and plankton, and the displacement of Arctic species with important consequences for commercial fisheries. More light due to the longer ice-free season and warming also affects the amount of primary production. Although there's a lot of uncertainty, we expect possible increases in at least some of the shallow shelves, and particularly increases in primary production along the slope regions, continental slope regions, but not in the Arctic basin, perhaps even decreasing production in the basin. However, even though there might be an increase in overall production at the bottom of the food web, where that production goes and how much of it goes to animals that we like to harvest, who the ultimate winners and losers are, remains to be seen. One concern is that smaller species will generally be favored in a warmer climate, which would lead to a longer and less efficient food chain, meaning less food for the fish and mammals that we value most. These and other changes, we highlight a few conclusions here that came out of discussions among scientists and with stakeholders. First, given the rapid changes, it's clear that we need more effective monitoring and new scientific approaches in these shelf regions, Arctic inflow shelves. Second, effective management across a changing mix of species in these regions will require further strengthening the ecosystem-based approaches that are already being used. Third, one thing that we heard over and over is that effective adaptation will require more flexibility in management to help minimize disruptions. And finally, some of the shifting fish stocks will require increased international cooperation. And with that, we look forward to learning more about some of the other projects funded by the Belmont Forum